Hi, and thanks for joining us for another great year of energy efficiency education. This video will walk you through the new secondary curriculum for the 2019-2020 school year. This year, you will be receiving a teacher guide which includes worksheets, answer keys, and background information, as well as a pre- and post-assessment and lesson plans to help with ease of instruction. Each of your students will receive a student and family guide which includes lab instructions, worksheets, and background information. Student guides are perforated to help with homework collection. At the end of the program, students will fill out a family installation survey to report back on which efficiency measures they installed in their homes and communities. This survey is extremely important to the success and continued operation of this program. So please, be sure that your students are filling out their surveys to the best of their abilities. Teacher tip: review the corresponding section of the survey as you teach each lesson in the energy efficiency unit. Students are more likely to remember what they have installed and report back accurately. Now, let's walk through each of the lessons in the secondary curriculum for this school year. Lesson 1. What is energy? A review. Lesson 1 is a review of basic energy concepts and is divided into 4 mini-lessons: energy forms and sources, measuring energy, energy economics, and energy efficiency and conservation. Also included in your alumni teaching materials, you will find 3 activities that are not in the guidebooks, but are helpful to supplement the guidebook lessons: base load balance, safety sort, and energy source matchup. Let's take a look at each of the supplemental activities. Base load balance. This activity demonstrates how electricity is generated to meet the demand of consumers. It encourages students to explore the differences between base load and peak load power and how power companies generate power to ensure customers have power as they need it. In your alumni teaching materials, you will find a hanging balance, background information, assessment questions, generation parameters table, and base load balance place cards. Using these materials, you will lead your students through a hypothetical day consisting of morning, all day, evening, and night. As the time of day changes, students will think about how their energy use changes and thus how energy generation must change. In this activity, paper clips are used to simulate megawatts of power, and students will use paper clips as well as the generation and demand cards to explore how the demand for generation of power fluctuates throughout a typical day. Safety sort. This activity includes instructions, an answer key, and 24 safety scenario cards. Students will read and sort safety scenario cards, determining whether each scenario represents electrical safety, natural gas safety, or both. Energy source matchup. In your teacher materials, you will receive a lesson plan, student recording sheet, and clue cards that will represent the 10 sources of energy. Students will work together to make a team of 4 that represents one of the 10 sources of energy. Prior to this activity, be sure to cut your clue cards up into 4 parts. Each of these 4 parts represents one aspect of energy source that the students will be exploring. Students will be exploring the economics, environment, availability, and safety considerations for each source of energy. At the start of the activity, give 1 card to each student in class. Their job is to interview their peers and find the 3 students that also represent the same source of energy. Note that each card contains a clue sentence and a search sentence. The clue sentence alerts the students to which above category they represent for their source. The search sentence alerts the students to what they should be listening for when interviewing other students. Once the student groups are found and formed, groups will fill out the student recording sheet. Each team will answer some additional questions and complete the table and list their source of energy advantages and disadvantages that relates to the 4 categories. To help supplement the background information provided in Lesson 1, a copy of the Energy Flows activity has been updated on our website with directions, a master set of all 10 sources of energy, and an answer key. All of Lesson 1's supplemental activities are made digitally for download on your teacher dashboard. Now, let's review the 4 mini lessons in Lesson 1. Lesson 1A, Forms and Sources. Lesson 1A is a basic review on what is energy and energy forms and sources. Lesson 1B, Measuring Energy. As students progress through the guidebook, they will recognize certain terms that pertain to energy. In this lesson, students are provided with the term, definition, formula, and unit of measure. You will also find another activity in Lesson 1B called Human Power. Students will explore how work and power are important energy concepts. In your alumni teaching materials, you will find a digital scale. To complete this lesson, students will need a stopwatch, 1 to 2 liter bottle filled with water, meter stick, pole or 1-inch dowel rod, and a thin rope. In groups, students will take the massive bottle of water in kilograms and record on the chart. They will attach one end of the rope to the bottle and the other end of the rope to the middle of the pole. Using the meter stick, students will measure the distance of the rope from the pole to the bottle and record on the chart. Have each person hold the pole horizontally so that the bottle is suspended in air. Students in each group will twist the pole so that the rope winds around it, lifting the bottle. Have a student in the group time how fast each person can wind the rope to bring the bottle all the way up to the pole. Record their time in seconds. Each student gets 3 tries. To complete the chart, have students calculate the force, average time, work, and power in watts for each person. An example of how to fill out the chart has been provided below. Lesson 1C, Energy Economics. In this lesson, students will study how energy production and consumption have changed over time. Using the timeline on page 14, students will complete the chart on page 15 above and answer some questions in the spaces provided below. Lesson 1D, Energy Efficiency and Conservation. Students will choose a sector of the economy and create 2 fictitious scenarios. In the first scenario, they will use a sector of the economy to describe a situation that shows good energy efficiency but bad energy conservation. Then they will use a different sector of the economy to describe a situation that shows bad energy efficiency but good energy conservation. Finally, they will reread both scenarios they have created and choose the one that would have the greatest impact on our total energy use as a nation and explain their reasoning. Home and Community. At the end of each lesson, students will complete the Home and Community worksheet. Students will continue to use their kit items to inform, educate, and change the behaviors in their homes and communities, but now they will take their knowledge a step further and research important topics and answer questions from the web quest and review careers connected to each of the lessons. Because of this new community focus, we encourage you to push your students to get their kit items installed where they can. We know that students cannot always install all of the items in their own homes, but encourage students to think creatively on where in their communities they could have a real impact. For instance, could a neighbor use that extra LED? What about a relative in need of a low-flow shower head? Our vision for this community-centric approach is to get students thinking how to make not only their own occupied spaces more efficient, but also how to make the spaces around them efficient as well. Note, in Lesson 1, there are no kit items to install, only questions to answer in the Energy and Action section. Lesson 2, Thermal Energy. Lesson 2 is divided into 2 parts. In Part A, students explore the concepts of heating and cooling and how different factors contribute to the heating and cooling system of a building. In Lesson 2A, students will discover which materials make the best thermal insulator. To complete the lab, you will need 2 insulation containers with lids, 2 digital thermometers, insulation materials, some hot water, and a measuring cup. Remove the lids from both containers and place each container in a testing container. Loosely pack insulating material around one of the testing containers. The other testing container will serve as a control. Pour 200 milliliters of hot water in each of the containers. Replace the lids of the containers and insert the digital thermometer and wait for the temperature to stabilize. Read and record the temperature of your thermometer at time 0. Using the chart, record the temperature of water every 2 minutes. Calculate the change in temperature for both containers and graph your results. Students will share their data with the class and determine the best thermal insulator. An additional activity from Lesson 2A is called the value of an R value. Students will use the map on page 30 to answer questions on the recommended R values for new wood-framed homes. R value is a measure of how well a two-dimensional barrier, such as a layer of insulation, a window, or a complete wall or ceiling, resists the flow of heat. Lesson 2B explores water and how it's treated, used, and transported. To complete this lesson, students will need an empty 2-quart cardboard carton, water, small sewing needle or push pin, graduated cylinder, stopwatch, metal rack or other objects to support the carton, and a beaker or cup to catch the dripping water. Using the needle or push pin, have students poke a small hole in the bottom of the empty carton. Support the carton with the metal rack or supporting object about 15 centimeters above the tabletop and fill the carton with water about half full. Leave the beaker or cup under the carton for 10 minutes. Using the graduated cylinder, measure the volume of water to the nearest milliliter. Have students calculate and record the rate of water loss on the chart below. Finally, students will investigate how much water they use in a single day by completing the Personal Water Use Survey. Students will keep track over a 2-day period the amount of time they use water and brainstorm some ways they could reduce their water usage on a daily basis. Lesson 3, Electrical Energy. Lesson 3 takes an in-depth look at electrical energy and how it is used. This lesson is broken down into 2 parts. Lesson 3A reviews the basics of electric energy and explores appliances and how they are used to contribute to the electrical usage. Students will first interpret and compare energy guide labels to help identify those products that help consumers make more efficient purchases. Next, they will review and identify the components that are included on a school electric bill and understand that although utility bills may look different, they typically contain some of the same information. Finally, they will figure out how much does it cost to power their classroom. To complete this lesson, students will need a computer spreadsheet program like Microsoft Excel and all the electrical devices in your classroom, a kilowatt meter, and a copy of your school's electrical bill if applicable. This lesson is broken into 3 parts. First, students will survey your classroom and find all of the electrical devices. Then, using the kilowatt meter, measure the wattage of each surveyed device. Once the wattage of each device is recorded, students will now calculate the total wattage of each device. An example has been provided in their student guidebooks. Finally, using a spreadsheet program, have students calculate your classroom and environmental costs for 1 month. Examples have been provided for students as a guide. Lesson 3B, Lighting. The lighting lesson is very similar to last year's, just with a couple additions, so let's explore. The lighting lesson incorporates 3 bulbs in the lab, incandescent, CFL, and LED, as well as digital thermometers. Place the lamps on the table and turn on the digital thermometers. Make sure that the thermometer is reading in Celsius. Next, tape the digital thermometers to the table so that the lamps shine directly on them. Before starting the lesson, have students note the package stated wattage of each bulb, as well as the package stated lumens of each bulb, and record the information on the chart. Have students record the thermometer readings every 2 minutes. After 10 minutes, students will calculate the temperature change for each bulb and record the answer in the space provided. In your alumni teaching materials, you will find a light meter. The light meter is used to measure the brightness or light that is hitting a surface. In this lesson, students will be using the light meter to measure the number of foot candles of each bulb. Finally, have students record the wattage of each bulb using the kilowatt meter and record their findings. After the lab, students will now compare the cost of each bulb, cost of electricity, life cycle cost, and the environmental impact of different light bulbs, and complete the graphic below. This year, we have added the halogen light to the list. Lastly, students will complete the home and community worksheet and install their kit items in their homes or community. Lesson 4, Energy Systems. After completing the lessons in the energy unit, students will now discuss and explore how energy usage works as part of a system. To explore this concept, students have two options. Option 1, Energy Audit. Before getting started, contact your school's facilities manager or your school maintenance staff to answer the school building survey questions on page 64 and 65. Assign a group of students to an area or room of the school to audit. Instruct students to use the student audit recording form, recommended lighting levels, and school building survey questions as their guide. Groups will summarize their findings on the Findings and Recommendations worksheet and present this information to a target audience. In your alumni teaching materials, you will find an infrared thermometer and a hygrometer to help students complete the energy audit. Option 2, Culminating Project. The Culminating Project is a creative hands-on approach to put students' knowledge of energy efficiency and conservation to the test and answer the question, how can my community become more energy efficient? Students are welcome to design their own project or use the recommended project design. Assign students in groups to develop a message, plan, and carry out their culminating project. Final projects should be presented to a target audience. Lesson 5, What have we learned? The Family Installation Survey will work the same as last year. It will be made available on the Ohio Energy Project website, as well as be available for download and distribution in hard copy. All surveys and teacher evaluations are due by April 15th. No extensions will be granted. Stipends and following year program eligibility will again be based on survey return. You will receive $100 if you return 50% of your surveys and $200 if you return 75% of your surveys. Teacher note. This year, we are asking teachers to have students complete the pre- and post-poll in their student guidebooks. On your teacher evaluation, there will be a space provided for you to record those results. This will help Ohio Energy Project collect data on the effectiveness of the efficiency program and students' knowledge gained post the energy unit. All of your login information will be the same as last year. Your username is your school email, your password is your last name. Thank you for reviewing the updates for the energy efficiency program this year. Please fill out the questions below and your supplies will be mailed to you. Have an awesome school year.